Hey y'all, today I'm going to cover how to do the assignment for today. I think we've been filling this in from the past, but if you need help, I'm explaining it, and some of y'all have not been able to make it on the Teams meeting, so here we go. Okay, so when we are asking for the symbol, we're referring to the periodic table of elements, and I want y'all to remember that there's always a key. So in case you forget which one's the symbol, it's usually the bolded abbreviations. Remember, it will always start with a capital letter, and anything following the capital letter will be a lowercase. So I'm going to do an example for you. We'll start off with, let's do fluorine. Okay, so fluorine is atomic number 9, and it's a capital F. Okay, so we're going to fill that in. So the symbol was a capital F. Oh, this pen's not writing like the way I want it to. It's atomic number 9. Okay, and remember, if we know the atomic number, we also know the protons and we know the electrons. So we can go ahead and fill that in as well. Okay, the mass for fluorine was, let's look, 18.998. So we are going to round that to the nearest whole number. So 9 and up means the score goes up. So, 5 and up, the score goes up. So that 18 becomes a 19. So our mass was 19. Okay, and then in order to find the neutrons with the mass minus your atomic number, so 19 minus 9 equals 10. Okay, now for the number of electrons. So all we're going to do here, we already have the electrons, they are 9. We're now going to place these 9 electrons into their energy levels. So the first energy level can only hold up to 2. So do we have more than 2? Yes. So we're going to go ahead and fill that in with a 2. Okay, so what's left over? So if we take away 2, 9 minus 2 is 7. So the second energy level can hold up to 8. So 7 is definitely under 8. So we're going to go ahead and put the 7. Okay, so did we fill the second shell? No. So what's going to happen is we don't have enough to even go into the third shell. So that is going to be a 0. Okay, and so the number of valence electrons, well, we just go back. There's none there, so this shell doesn't exist if it's a 0. But the last shell that it does have is a 7, so that is going to be 7 valence electrons. Let's do another one. Let's try magnesium. So we're going to go up here. Magnesium, the symbol is a capital M, lowercase g, and is atomic number 12. So we're going to put that here. So capital M, lowercase g, it is atomic number 12. Sorry, I'm kind of moving around. Okay, and we said the same thing. So if we know the atomic number, we know the protons are 12. And we know the electrons are 12. Okay, now for the mass. The mass for magnesium is 24.305. Okay, so we're going to go ahead and it is below 5, so the score stays the same. So 24. Okay, so 24 minus our 12 protons is going to equal 12 neutrons. Okay, now once again for the electrons, we are just going to place these 12 electrons in their shells. Okay, so once again, how many fit in the first shell? 2. Okay, how many fit in the second shell? 8. Well, 8 plus 2 equals 10. So we definitely have enough for that. So 8. Okay, so if we have 10 here with the 2 and 8, how many are left to place in the third shell? 2. Okay, and then for our valence electrons, we always just look at the outside energy level, okay, or electron level, and it is a 2, so we just write 2. Remember, if it is a 0, that energy level does not exist for that atom, so you go to the next inside level. Okay, I hope this clears it up, and I hope you have an easier time filling this in. If not, I will be checking my email. Thanks, and have a good day.